Hello everyone, I'm Ashratuz Zavin Asha. I'm a master's student at the University of Calgary. Today I'm presenting our group's work, Co-Designing Interactions Between Pedestrians in Wheelchairs and Autonomous Vehicles. This work presents our design exploration to implement inclusive interfaces to improve interactions between autonomous vehicles and vulnerable road users, such as pedestrians in wheelchairs. So I'm going to start off by looking at the recent works on AV pedestrian interaction done by the practitioners and academics. We can anticipate that in the near future, mixed traffic consisting of manual and autonomous vehicles will be common. Many manufacturers such as Waymo has already launched their self-driving taxi service in Arizona. Some has introduced ways how to communicate with pedestrians, such as the smiling car concept. This car smiles when it is safe to cross the road for the pedestrians. Numerous HCI studies have explored how vulnerable road users like pedestrians will respond to the introduction of AV technologies. These works have found that explicit interfaces, those are placed on the vehicle or on the street infrastructure, could greatly improve pedestrians' ability to make safe crossing decisions when they need to share the road with AVs. Such as Madhavan et al.'s work instigated interface prototypes that explicitly communicate awareness and intent of AVs to pedestrians in crossing scenarios. They implemented interfaces that contained LED strips, animated faces, phone haptic, and also they explored the importance of having multimodal interfaces. Another work explored 3 external car displays with visualization concepts such as this smiling grille, traffic light indicators, and a gesturing robotic driver. Recent research projects mainly focus on designing AV pedestrian interactions for non-disabled adults. Inclusive interface concept designed specifically for people with disabilities and AV interaction are still underexplored. However, we have seen Coley et al. Proposing concepts that established inclusive communication between pedestrians with vision impairment and AVs. They found that multiple vehicles communicating with high content messages for a longer duration could reduce cognitive load for such users. Our recent work aimed at understanding interactions between AVs and pedestrians with reduced mobility focused on wheelchair users and presented brief results from a design study on possible interfaces with interaction designers. However, this work concluded with a primary design study, and their presented interface concepts need further evaluation with the people who used a wheelchair. So from the statistics, we can see that 48% intersection crashes involved wheelchair users in a crosswalk. In addition to that, the lowered position of wheelchair users could also contribute to the increased pedestrian mortality rate. Also, unsafe interactions act as an environmental barrier to the mobility of the wheelchair users. When AV will be there in the future traffic, missing driver communication could make road crossing decisions even more difficult for the pedestrians in wheelchairs. So overall, questions surrounding how external interfaces can be designed for people with disabilities to communicate with AVs needs to be explored. So we asked ourselves, how can we provide a safer crossing experience to vulnerable road users such as pedestrians in wheelchairs in the presence of future autonomous vehicles? Now I'm going to talk about the methodology that we followed in our co-design study. Our work is concerned with designing accessible interfaces for a specific group of people, pedestrians in wheelchairs. Therefore, we applied inclusive design practices as it studies diversity and uniqueness. Inclusive design approach under the one-size-fits-one design umbrella considers how designing for one can be extended to many. Our co-design sessions were conducted with a single co-designer who is also an author of this work and has the lived experience as a powered wheelchair user. We conducted 4 sessions with 2 iterative design sessions with the same participant that provided us rich and in-depth reflections. For the co-design study, we followed the design guidelines described in the Microsoft's Inclusive Design Toolkit, as this toolkit has many activity cards and methods that provide design principles when designing for inclusivity. We designed and tested all the interface prototypes in virtual reality, which allowed us to conduct the study remotely. So this is our overall co-design process. We had 4 sessions. In the first session, we had an interview with the co-designer where he mentioned his life experience, strengths and abilities and challenges, especially while crossing the roads in current traffic. In the second session, we do the study setup by introducing the co-designer with the Oculus Quest headset and the haptic device that we designed for generating vibration. The last 2 sessions are the iterative design sessions. In the first session, we evaluated some initial prototypes based on the literature and our interview session. Based on the collective feedback, we revised the interface prototypes, and again after evaluation, we gathered design insights from the co-designer on how interfaces might provide effective AV-PW interaction. So for the first iterative co-design session, 2 base scenarios were there, where in one scenario we added a manually driven vehicle with a driver, and in another scenario we had an AV with no driver inside the vehicle. There were 5 other scenarios with interface cues considering different modality, location and crosswalk type. And all the scenarios were implemented for uncontrolled crosswalk. So while designing interface prototypes, we included some design ideas that were inspired from the initial interviews about the co-designer's lived experiences, such as adding the push button on the wheelchair, as the co-designer mentioned that in some signal intersection, push buttons can be difficult for a wheelchair user to reach. Secondly, we tested simulations in an abstracted crosswalk to find if the design interface cues were effective to make the crossing decisions, as it was difficult to see the upcoming vehicle due to the obstruction. We also added on-wheelchair interfaces to see if it helps to interact with the vehicle for the wheelchair users when it is difficult to perceive the road traffic and signals due to being at a lower height. So while designing different interface prototypes, we considered different variables such as modality, location and crosswalk type for our interface cues. In the modality section, we have 3 types of interface cues. One is visual cues such as wheelchair symbols or street LEDs. And then we have audio.
Don't cross. The car sees you. Cross.
And haptic feedback to generate vibration to alert the pedestrian when it is safe to cross the road. We implemented the interface cues in 3 different locations such as wheelchair, vehicle, street infrastructure. For the crosswalk type, we implemented the interface cues for 3 different crosswalk: uncontrolled crosswalk with no street lights, controlled crosswalk with a countdown timer and street lights, obstructed uncontrolled crosswalk. The interface simulations were tested by the co-designer in VR, and the simulations required the co-designer to observe different cues without crossing the road. We asked him a series of questions to gather insights on the presented interfaces, such as what information did you look for before making a crossing decision, which cues or location of the cues made you feel most confident in making a crossing decision. Now we are going to discuss the findings from our first co-design session. The co-designer liked the push button as an additional tool beyond the buttons that cannot be accessed at the crosswalk by people with disabilities. However, he suggested to use the push button for a controlled crosswalk to make the crosswalk scenario more realistic. The co-designer did not prefer the audio cues that were playing from the wheelchair because it might bring unwanted attention to the wheelchair users. So the co-designer suggested to use universal crossing symbol, as these are widely known as pedestrian crosswalk symbols instead of the wheelchair one. There was another suggestion to use an intermediate state, including the start and stop state, to represent when the vehicle is about to stop or when it is going to drive again. For the second iterative co-design session, we have revised the interface prototypes based on the feedback gathered from our previous session. The interface prototypes were tested both for uncontrolled and controlled crosswalk. We added a universal crossing symbol instead of the wheelchair one with an intermediate state. We also introduced a control crosswalk with a timer that can be increases when the push button will be pressed for the second time. Now we discuss the design considerations based on the overall insights gathered from the co-design sessions. The interfaces on the wheelchair are important as it would allow to understand vehicle's intent when it is difficult to perceive vehicle speed or other street cues. Haptic feedback can be considered as a fail-safe cue when the visual cues are not provided or perceived. All visual cues were generally useful, but there were some concerns regarding the visibility of the laser projection in bright light conditions. Familiar and common cues will be more easily adapted as our co-designer preferred universal work symbols, also the countdown timer, which we can see already in our current traffic. Interfaces on the AV were considered as more reliable due to having direct physical mapping to the vehicle. Finally, AV-PW interaction prototypes could be adapted for other pedestrians as well, such as visually impaired pedestrians or older adults. For example, the haptic AV-PW interface could be implemented in a wearable or personal phone, or also can be integrated in other assistive technologies such as in a cane or in a walker. As a future work, perspective of multiple co-designer can be explored that would allow more diverse design ideas and work for a larger group of people. Future studies should explore additional interface designs scenarios by including multiple vehicle and pedestrians and considering the practicality of the proposed interface cues. So the main takeaways from our work are mentioned here. External AV-PW interfaces might establish a sense of trust and confidence for pedestrians in wheelchairs while crossing a street in the presence of autonomous vehicles. Empathy and sensitivity need to be in the AV-PW interaction design so that we can design careful interface cues without creating new social stigma. Interfaces need to be adapted and customized by considering individuals' needs and challenges so that it works for the larger community. This is the end of our talk. Thank you everyone